When a PulseBoard member publishes a post, the product may need to store the post, update follower feeds, index text for search, resize images, send notifications, and write analytics. If the request waits for every one of those actions, one slow dependency turns a simple publish into a slow and fragile experience. The better question is, what must complete before the user hears success? For PulseBoard, durable post storage and a clear acknowledgement matter immediately. Search indexing and notifications can happen shortly after. This creates an intentional boundary between the synchronous command and asynchronous follow-up work. After the post transaction commits, the system records an event such as post created with a stable identifier, author, timestamp, and version. Consumers use that event to do independent work. A feed worker updates a read view. A notification worker decides who should be notified. A search worker updates its index. An event is not a command telling every consumer how to behave. It is a statement that something happened. That distinction makes services less coupled. It also requires discipline. Consumers must handle duplicates, delayed delivery, and schema changes because distributed delivery is rarely exactly once in the way product teams imagine. A queue stores work between the producer and a worker. During a traffic burst, it lets the publish path remain fast while workers process at a safe rate. But a queue does not remove capacity limits. If producers add events faster than workers finish them, backlog grows. PulseBoard measures queue depth, oldest message age, worker success rate, and retry count. Those metrics turn asynchronous work into an operational promise. A queue is useful when work can be retried or delayed. It is dangerous when the product needs an immediate answer and the system hides a long delay behind a successful button. For a small account, PulseBoard can write a post once and assemble follower feeds when each reader asks. For an account with millions of followers, that read-time work may become expensive. Fanout on write pushes a reference into many feed views ahead of time, making reads fast, but making one publish more expensive. Many real systems use a hybrid. Fanout normal accounts, handle celebrity accounts differently, and cache popular views. The important lesson is not a magic pattern. It is the ability to explain where work happens, when it happens, and who experiences the delay. In the local event board simulation, a post commits once and places one event into the queue. The notification worker fails on its first synthetic attempt. The queue delays the retry with backoff, and the second attempt succeeds. The feed worker sees the same event twice after a simulated delivery retry, but its idempotency record prevents a duplicate feed item. A poison event that cannot be processed moves to a dead letter record with the error and original payload reference. The original post is still durable. The system did not silently drop work or make the user repost. When backlog grows, teams need a safe response. Add worker capacity only if the downstream database or API can handle it. Degrade non-essential notifications. Slow producers through quotas. Pause a broken consumer rather than repeating a damaging action. Alert on message age, not only queue length, because a short queue of stuck messages can matter more than a long queue draining quickly. Back pressure is how a system communicates its real limit instead of allowing every component to overload its neighbor at once. PulseBoard now commits the post before it emits follow-up work. Workers are idempotent, retries are bounded, and dead letter records are visible to an owner. The user-facing contract says feeds and notifications can take a few seconds. That is an honest, scalable promise. One final layer remains. We need to know whether these promises hold in production, and we need to protect the boundaries that connect every component. Episode 6 turns the course into a production operating model.